Good morning, everybody. My name is Richard Newman, and today I'm going to talk about Platonic solids. What is a Platonic solid? A Platonic solid is one of five regular solids, namely tetrahedron, cube, octahedron, dodecahedron, and icosahedron. Every solid is special, the reason being every face is a regular polygon of the same size and shape. Next, we have the tetrahedron, where we get the solids, the nets, the faces, the verticals, and the edges. As we can see by the solid, the tetrahedron is formed in its final shape. The net is a layout of the tetrahedron and how to combine it to make it in its final shape. As we can see by the tetrahedron, we have four faces, as we can count 1, 2, 3, 4. Four verticals, as we can also count, is like 1, 2, 3, 4. And 6 edges. There's 1, 2, 3, 4, 5, 6. Next we have the cube. Also in the cube we have the solid, the net, the faces, the verticals, and the edges. By the solid we can see the shape in its final form. By the net we can see the layout of the cube. And we can also identify the faces, the verticals, and the edges. In a cube we have 6 faces, 8 verticals, and 12 edges. The octahedron gives us the solid, the nets, the faces, the verticals, and the edges. By the solid we can see the form in its final shape. The net gives a layout of the octahedron and how it needs to combine or compile to make it in the final solid shape of an octahedron. In an octahedron we get 8 faces. You can count 1, 2, 3, 4, 5, 6, 7, 8. 6 verticals. You can also go 1, 2, 3, 4, 5, 6, and 12 edges. Next we have the dodecahedron, where we get the solids, the nets, the faces, the verticals, and also the edges. By the solid we can see the final shape or form of the dodecahedron being combined. Next to it we have the net, the layout of the dodecahedron on how the dodecahedron need to be formed or combined in order to get the final solid. We can also get the faces, the verticals, and the edges of a dodecahedron. As we can see in the net, we can count the faces of the dodecahedron, where we can count 1, 2, 3, 4, 5, 6, and if you take the 6 multiplied by 2, because we have 2 sides, then we get 12 faces. A dodecahedron has 20 verticals and also 30 edges. Next we have the icosahedron, where we can get the solid, the net, the faces, the verticals, and also the edges. By the solid we can see that the icosahedron is in its final form or shape combined. Next to it we have the net. The net is the layout of the icosahedron on how the icosahedron need to be formed or combined to get the final solid. As we can see on the net, we can count the faces, the verticals, and also the edges of an icosahedron. In an icosahedron, we have 20 faces, 12 verticals, and 20 edges. Finally, we have the octahedron. The formula for the total surface area. The area of an octahedron is 2 multiplied by the length of an edge squared multiplied by the square root of 3. So a is equal to 2 multiplied by a to the power of 2 multiplied by the square root of 3. Keep in mind that a is equal to the length of an edge. For example, calculate the surface area of the octahedron with an edge of 5. The solution is as follows. Formula is a is equal to 2 multiplied by a to the power of 2 multiplied by the square root of 3. A is equal to 2 multiplied by 5 to the power of 2 multiplied by the square root of 3. So a is equal to 2 multiplied by 25, because 5 to the power of 2 gives you an answer of 25 multiplied by the square root of 3. So your answer a is going to be equal to 86.6 squared inches. So the edge of 5 is going to be 86.6 square inches. Thank you for watching the video. I hope you enjoyed the video and have a nice day. Thank you.